Well, let's start today's class. Please let me know if you have any problems with uh, my voice and my camera. You can type in our cutoff. Well, again, this is a draft book which I share with you. The title is The Hydrogen Technology, a Comprehensive Guide. This book will be updated through our course. And the version I shared is the version 3. I will keep updating and then share with you. I hope that you already read this overview of this book. Actually, the purpose of this class is to review all the technology related to hydrogen, why hydrogen energy becomes so popular and important. And we as an engineer, especially mechanical engineer, need to understand the hydrogen energy, no matter what we do as a researchers. So it is critical to understand in general the energy, but especially the hydrogen energy. How to produce a hydrogen gas and how to uh, distribute hydrogen gas and how to store the hydrogen gas and also how to generate electricity from hydrogen. So there are four different distinct areas related to hydrogen society where we are fully use of hydrogen gas. This one simple figure show us the the category of hydrogen energies, hydrogen productions can be from renewable energy. That is very important. Renewable energy is the mainly from wind turbine blade and solar cell. And another source of hydrogen energy production is the we call gray, which we will cover today. And steam reforming is an important method of generating or producing the hydrogen gas. And there is this method of hydrogen production is through electrolysis or electrolyzer. We need water and electricity. We generate H2 hydrogen gas. And the steam reforming and cracking, we use the CH4 methane, uh, uh, and we get the H2. We will review how to produce the hydrogen today. So there can be very different methods depending on the method and depending on the source of electricity. So we color them. There are many different color depending on the method. So anyhow, once we have a H2 hydrogen gas, we distribute hydrogen gas through a pipeline or through a convert to ammonia. Ammonia NH3 is the so important material, and this once we convert into ammonia NH3 is very easy to distribute, especially for long distance traveling. And the very conventional, very popular way of distribution is through a pipeline. We call hydrogen pipeline. And this is for the short or mid-range distance. And then at the end, we as a user, this hydrogen gas reach the residential applications and also a fuel cell vehicle as a mobility and buses and trucks and train and so on. So in this stage, we certainly need a hydrogen storages. So of course, in this at the end, we need a fuel cell to generate electricity from hydrogen gas. So production, distribution, and storage, and generate electricity. So you read these short descriptions about this figure, and there is a terminology called electrolysis. Electrolysis is these procedures. This is a simple, the most simple procedure. We just decompose the water into H2 and O2 using the electricity. That is the electrolysis. And steam reforming and cracking is the other most important methodology. Using the fossil fuels, and this contains mainly CH4, methane, with the, and also very important, we need to capture the carbon carbon capture and storage, we call CCS, to produce hydrogen. So we will briefly review those two methods. And we will cover or emphasize from time to time what is the grid, concept of a grid. Grid is a very important concept, especially these days. How to effectively distribute power or energy through power line. There can be many different energy source or many different way of storage. So hydrogen can contribute to the energy grid, and it implying its role in balancing and supporting electricity network. This is the very important concept, grid. I hope that you can, I would like to say grid for AI. These days, AI technology becomes the, oops. AI becomes very popular, and AI, as he says, AI is revolutionizing electricity grid by enabling smarter and more efficient. So AI can be used to revolutionize the electricity grid, but more importantly, the grid, efficient grid is quite needed, mainly because of AI, which requires a lot of energy. When we search using the AI, it requires a hell of a big amount of the energy. Then and the energy is more than needed for age of AI, and so the importance of a grid becomes much more important uh, than ever. So anyhow, concept of a grid is important. The ammonia, NH3, is also important as a carrier of the hydrogen gas. Well, NH3, again, can be very easier transportation, and especially for country-to-country export purpose. as ammonia or NH3 contains the H, and we convert the H2 into combined with N2, that nitrogen, and then we got the ammonia. This is a much safer way of transportations. But there is also pros and cons. It is a kind of a toxic. And then we also need energy from converting hydrogen to ammonia, and then also ammonia to hydrogen. We lose energy. So that is also important concept. Anyhow, as we briefly review our this book of hydrogen technology, chapter 1, we just briefly review the hydrogen gas and global trend and policies relate to hydrogen gas. Please read this chapter 1, and then together with reading these books, I hope you find your own search the articles relate to each topics. I just listed the important points related to introduction to hydrogen gas. Hydrogen as an element energy carrier is important to understand the hydrogen as an energy carrier, which is quite different concept of the conventional energy source like the petroleum-based. Property hydrogen gas, H2, and the environmental energy crisis. That's why the hydrogen become so critical, so important, and the hydrogen will become more and more important than ever. And global trend and policies on hydrogen gas. Each country, they may have different policies on the energy, especially on the hydrogen gas. But in general, the global trend is much moved toward the intensive use of hydrogen gas. While hydrogen is not a new energy carrier, it has its own historical context. Now, today, we like to mainly cover the chapter 2, hydrogen productions, how to generate hydrogen gas. Well, hydrogen gas itself is a very, I would say, has a high energy density and is very, can be very unstable and very difficult to carry. How to effectively generate hydrogen gas. So chapter 2 covers the hydrogen production, while conventional and emerging method, just the general overview of hydrogen production. Gray and blue, I'm sure you heard many times about the green hydrogen, gray hydrogen, and blue hydrogen. And chapter 3 also, as an extension of chapter 2, is green hydrogen versus the other advanced production technology. So green hydrogen via electrolysis, and yellow hydrogen, white hydrogen, and nuclear hydrogen, and scalability and challenges. So chapter 2 and chapter 3, these books are dealing with how to produce the hydrogen. And today we like to cover chapter 2 and chapter 3 as much as we can. Okay, once we cover the how to produce the hydrogen, and then the next chapter will be how to distribute hydrogen. using the pipeline, using the trucks and ships, and so on. And chapter 5 is how to store the hydrogen gas, either compressed or liquid, and so on. And chapter 6 is another advanced method of hydrogen gas, hydrogen storage, not just the compressed gas or liquid. We can use the metal hydride. This is very safe, and this is the ongoing technology, which the most ideal way of hydrogen storage. Using the metal hydride, we don't have to compress the hydrogen gas. We just use a metal or chemical storage. Chemical storage means that we combine H2 into another organic materials and then become very stable, like the methanol. And so this is the another way of a chemical storage. So anyhow, there's a cryogenic compressed storage as well. So chapter 5 and chapter 6, as you can see, that how to store the hydrogen. And chapter 7 is the electricity production from hydrogen, mainly using the fuel cells. Overview, there are different types of technology, PM or SOFC, AFC, and so on. We are trying to improve the efficiency and performance, and also lower the cost related to these hydrogen productions. And the special chapter is the chapter 8, hydrogen combustion system. Well, the internal combustion engine is the most conventional engine, which use the conventional gasoline or petroleum-based energy source. But we can still use the H2, hydrogen, using the internal combustion engine. Rather than generating electricity from hydrogen, we just directly use the hydrogen as the combustion energy source. So this technology also important to understand for engineers. And then hydrogen in land mobility. Now hydrogen can be used as a electricity source and fuel cell electric vehicle, like the Nexo and the Mirai in Japan and Korea. Globally, a lot of automotive companies try to develop the fuel cell electric vehicles, and the hydrogen trucks and buses and trains and infrastructures. And the last week, the homework was mainly related to this technology related to fuel cell electric vehicles, and compare with just regular battery type electric vehicles. We need to understand the difference between the fully battery type BEV versus FCEV. And of course, the battery technology becomes so much popular, and there are many different, I guess about 10 different types of batteries. The most typical and popular methodology is the nickel chrome mangan NCM based the anode, and then cathode. There are we can generate, or we can store the electricity using such rare materials. But battery become sort of problematic in terms of life, in terms of recyclability, and in terms of charging time and so on. But we also believe that such a problem can be overcome by advancing technologies. but it's always the matter of the cost and the total mass and recyclability as well, or initial investment. So as an engineer, we need to understand not only technology, but also all the costs related to each technology. We need to, our main goal is to lower the cost so that any technology we develop as engineer should be well utilized for human uh, life and comfort. So anyhow, the battery is the most important way of storing energy, electricity. I I hope that we can cover that topic briefly. And then hydrogen in air and sea mobility. Sea mobility is a way of transportations, and the land type and air and sea mobility, like the drones and ships, eVTOL. eVTOL become very popular. The vertical type to take off. The so the how can we fully utilize the hydrogen as an energy source or power source for this mobility system? And the So chapter 9 and chapter 10 is the devote to such applications. And chapter 11, hydrogen and smart grid, again, the concept of grid and the economics of hydrogen energy. The energy become I would say, yes, one of the most affecting the economics of any countries. So economics relate to hydrogen, and the is important. And environmental impact of hydrogen. This is a very obvious topic. We need to why we have to use the hydrogen. So the chapter 14 and the future trend, and chapter 15. 15 is the is a very special chapter. We especially in Asia, Korea, China, India, and of course Brazil, we relatively lack of energy source, conventional oil and gas, and how can we fully utilize the hydrogen as an energy source and carrier. So it will be a great chance for us to overcome the lack of the energy source. Just the beyond green means that hydrogen is not just to clean the environment. Hydrogen can be a strategic lifeline for many countries, with Korea and China and etc. So there are a list of some important topics. Okay, well, the last week, of course, I review and these major topics covered in each chapter, but we review the topic again because the hydrogen, this class is relatively new to engineers, especially for mechanical engineer. We need to make ourselves familiar with this concept of hydrogen. Why do we need to use hydrogen? Why do we have to study? How to prepare for future, considering the hydrogen? And so no matter what research you guys do, it is important topics. Okay, so as you mentioned, chapter 1 is the covers the introduction to hydrogen and then it gives us some introduce some values, numbers, and the as an important figure, hydrogen energy content is the about 120 megajoule per kilo. This is the important number we need to remember. In other words, 1 kilogram of hydrogen can contain 120 megajoule. Well, megajoule is kind of difficult to understand, but this we need to get used to this number. And as I mentioned today, how to generate this hydrogen gas, hydrogen production of hydrogen, conventional emerging method. There are I don't want to just read line by line here. You got, please you read all the important the numbers and concepts, and the you can often find some numbers, say $3 to $6 per kilo. And the okay, I like to use the some slide I prepared. This slide also will be shared to you, and the okay. Well, just browsing the content. Gray hydrogen. Gray hydrogen is related to CH4, methane or methane, CH4, and plus H2 is a steam. So CH4 plus H2O giving us the hydrogen, but unfortunately there are a lot of CO. Which is the it's not a good material. CO is produced as well. So how to capture this CO? Depending on how to capture this CO, we have the technologies called either gray or blue, and so on. So it's important to understand the method. It's called steam methane reforming. In short, we call SMR, and compare with electrolysis. This is the second most important method, a very conventional methodology. So gray hydrogen and blue hydrogen, while same method, same chemical formula as a gray hydrogen, but in here we capture the carbon and store. So carbon capture storages, CCS technology is added. So reducing SMR emissions, 1 to 2 kilogram of CO2 per kilogram of H2. So this is a much less causing CO2. So blue hydrogen is certainly is much better than gray hydrogen. Again, gray hydrogen can cause the CO, but the blue hydrogen, we have to have another methodology. It's called CCS or CCUS. And then there's a green hydrogen. Green hydrogen is the, as I reviewed, the methodology called electrolysis. So water can be converted into H2 and the oxygens. And from here to these, we need energy. So we have to put a lot of energy required to split H2O into H2 and O2. And depending on the methodology, we have different PEM and alkaline methodologies. And the emerging method means that there are several different methodologies, and also is important to understand the energy input and output and efficiency and initial investment. There can be several methodologies, but which one is the most cost effective and most maintenance effective? So we also need to understand in addition to technology. So I like to use the slide. Let's first compare the green versus blue versus gray hydrogen. So green, so electrolyzer or electrolysis, this method is the key in the green hydrogen. Well, as you can see that depending on the technology and energy source or method of generating hydrogen, we give them a color, green, blue, and the other gray, and so on. So green, the energy source comes from the PV or solar cell or wind turbine. They are called renewable energy. Well, it's purely from naturally we can get this energy, but there can be a very much the initial cost is high. And then sometimes we need to store them, but in this case, battery is not important. There's an energy source directly come to here, and then water comes there. So this will be H2O, and then decompose into H2. So this one comes to H2 plus O2. So we have to add energy. So this is the we need to add energy to generate hydrogen and oxygens. So this hydrogen can be stored and then distribute, and then we can use them for fuel cell or the vehicles and trucks and etc. This is the most ideal case of the generating hydrogen gas. Now the blue or gray is that CH4 methane or methane. So CH4 is a natural gas, and which also coal can contain a lot of CH4 methane, and then this can be we can think as just a natural gas can be distributed through a conventional pipeline, or can be compressed with a little high pressure, and then this is a reforming. Reforming is the using water. Actually, the steam, and then reforming procedures. So CH4 basically this is a water steam. It gives added H2O is added. So CH4 plus H2O giving us the H2 and the CO2. So as you can see that if there is no capture, CCUS, carbon capture uh, uh, storage system, if we don't capture them, this is the called blue. This hydrogen is called blue. While this blue can be stored and added to this hydrogen, then can be distributed. So this green hydrogen or blue hydrogen can be combined. This is the conventional or current method of generating hydrogen gas. And then this CO2, rather than just releasing to environment, we can capture into the method CCUS. Then this method called, oops, sorry, this method called blue. If we don't capture this method called gray. So gray and blue, there's not much difference. Only difference is the whether this CO2 is captured, stored, or we don't do. So gray and blue and green. This is the current, the most the way of generating hydrogen. And then, well, I just mentioned that gray hydrogen is the as you said, same production process as the blue hydrogen with the CO2 released into the air. That is the nothing but called the gray hydrogen. And pink hydrogen, where is it? Pink, the electrolysis. This electrolysis, this is a electrolysis. Now the energy source is rather than renewable. Rather than renewable, we use the nuclear power, nuclear energy. Then it is called the pink hydrogen. Well, not much different, but the small modular reactor, this is called another called small modular reactor. Very important the nuclear power system. Well, don't get confused. This is also called the
HSO, energy solution.
and the this is also called the we call the so SMR is a small modular reactor. Also very important the method or technology in the area of nuclear power source, power energy generations. So using the SMR, SMR will become very popular. So as using the SMR, if we generate hydrogen, the hydrogen called pink hydrogen, and yellow hydrogen is, I guess, one of the most recent advanced technology. So pretty much the same as this method, but the rather than renewable, rather than the nuclear, we use the solar power itself. This is different from PV. PV is the electricity generated from solar power. So this is the electricity, but this yellow is the rather than generating from sun, we just directly use the solar power, not the electricity, solar power to split H2 into H2O into H2 and the O2. So with this technology, we don't have to go through this step, so we can increase the efficiency. So this technology called the yellow hydrogen. Okay, well, so you can see that there are different colors, and I similarly I little bit add more method with the detailed characteristics, and this reference is refer to the site, the Wikipedia, hydrogen production. You can easily find. Okay, let's go through this. This is relatively short form. This is a complete form, and as we just covered, we have equal brown and black, but we in general we call this is a gray, and the white and gray and blue and turquoise special color, and red and purple or pink and yellow and green. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There can be a little more. So anyhow, you can further find more information in this website. Anyhow, the fuel source is the coal, basically the CH4 actually. Then white, I will we will get back to more. This is a natural H2. It is a very important concept as well. And gray, oops. Oh, there are slightly distinguished between the, I'm sorry, this is the, I should not say this. This is not the gray, it's yeah, they sometimes call brown and black. This gray and black is almost the same, but the rather than direct CH4, this is a natural gas, and the coal also have a basically the CH4 contains a lot of CH4, but the direct from coal we call brown and especially black and gray. So this is the blue, as I mentioned, the CCS captured. So this is a CH4 and CH4, and actually this is also CH4. So the okay, so this guy. I would say this guy. Oops, well, it's okay. This guy and this guy and this guy, they are all use the the CH4 methane CH4, and as you can see, steam reforming and steam reforming procedures. Well, it is called the pyrolysis. Pyrolysis is usually you're adding a lot of heat, temperature to to split the CH4. So the basically the source is all the CH4, and the this method is steam reforming. Steam reforming is you add H2O. The last one is the CH4 natural gas, but the pyrolysis is the just a split C and H. C and H is just a split without adding H2O. But again, the important concept is we are all using the CH4 methane as a fuel system. And then a product, as you can see, that CH4 plus H2O giving us the H2 and CO2 is released or captured, stored, and this is also released, and this is the solid. So as you can see, we got all the H2, but the CO2 is the not a desired materials, so we don't want CO2, and the CO2 is captured. This is a relatively better than other methodologies. And the other four is the gray. Well, there are, well, purple or pink, we just mentioned. This is yellow, and this is a green. Well, there is another color called red, not much different, but as you can see that this method usually mainly electrolysis, water splitting, water H2O decompose into H2O, decompose into H2 and O2. And this nuclear, same nuclear power here, same nuclear power here, but catalytic splitting means that H2O just split H2 and the O2, but we can have a same concept, red and pink, in terms of a nuclear power source. So we get the H2O, and the yellow, we just mentioned the solar power as energy source, but the methodology is electrolysis, H2O. H2O is the H2 and O2. And renewable energy source, solar cell, and also a wind turbine, we get the H2. So this is the very much common coloring system for the hydrogen energy source. As you can see, there are two big groups. One is the fuel source is the usually natural gas CH4, or process is this is the I would say electrolysis like method, and then a different energy source. I hope that this coloring hope to help you better understand all different methods of the hydrogen productions. Okay, it is 3:55. Let's have a 10 to 15 break. Let's come back. Okay, so we start to review the whole methodology of a production of hydrogen gas and energy by color. As we noticed that there are two big different groups. One group is to use the CH4 methane as a fuel, and the second group is the relate to electrolysis method, where we can convert H2O directly to H2 and plus O2. Of course, in this procedure, we have to add energy or fuel to get the H2. So, as we reviewed the last week, I like to say just to better understand conceptually the concept of the hydrogen gas and the I would say green hydrogen. Green is the one here, the green hydrogen. So let's say vertical axis represent the energy level, and the conversion method. I would say the zero level, relatively zero level. I would say the H2O. So this is a water. Let's imagine that H2O has no energy relatively. And then this is the H2 energy level for the H2. So as you can see that H2O and the H2 has a big different level of energy. So to convert into, convert H2O, bring it up to H2, we need this much energy. This much energy needed or added to the convert into H2. So H2O, of course, there will be O2 released. So the H2O becomes the H2 plus O2, and this much energy. I will call this energy. So this much energy needed to add it, apply to convert H2O into H2 plus O2. So the H2, you can see the energy level is very high. And then this H2 can be transported from a position to A to B.
나는 우리나라만 유행하는 줄 알았는데 외국이 유행할 수 있어. MBTI 외국에서 유행한 거. MBTI 이제야 유행시지 않았어. 몰라, 나도 누가 한 거길래 나도 뭐 F나 T하고 본인의 MBTI라고 하구나. 내가 되게 되게 모르지. 나는 이게 난 한국에서 유행한 줄 알았어. 스위스.
Okay, so H2 energy level got much higher with this added energy, and we generate H2 and plus O2. Now this H2 can be distributed, or we can imagine that distribute from A position to B position, and you need a method. And sometimes you need a storage system you can have stored. But the big advantage of H2 is that this H2 energy level, whether it is distributed from A to B or stored over the time, the energy level of this H2 not change much. Not like the battery. Battery, whenever they store over the time to time, the energy level is a decay. And the so anyhow, whenever we have a H2, we can use them as we can extract energy or electricity and then down to water. So this is the H2 plus O2 and become the H2O. So in here, of course, we got the energy out. Of course, the initial this energy and then this energy in and energy out, there are two different, there is a different efficiencies. So we also need to understand that one. I hope that this can help you to visualize the green hydrogen. So this procedure is the electrolysis or electrolyzer. So basically, this is the procedure of electrolysis, and then energy level or energy, I mean, the H2O is the source of the these procedures. So H2, as we notice that H2 is the energy carrier. Carrier means that H2 has a certain level of energy, and then it can distribute and it can store with that much energy in there. So this can be very convenient in terms of distributions, in terms of storages. Not like the direct electricity. Direct electricity is very difficult. It cannot store electricity itself, uh, uh, but the hydrogen can be stored and can be stationary as long as we want, and then we can get the energy out. So there is a concept of the P2G. P2G concept is important. Power to gas. Power means a conventional electricity now convert into a gas. Gas means that hydrogen. So P2G is the trend of the energy. So whenever we have energy, we convert it into a gas, hydrogen, energy, hydrogen, and then we can distribute rather than just the electric wires. Because energy through electric wire can a lot of energy we can lose the energy. So there are huge advantages with the P2G. That's why not only Korea but also many countries are moving toward this new paradigm of the P2G. So understanding P2G is the critical. Okay, so well, this is the one we already mentioned last week, but I like to emphasize this concept. So this is the electrolysis, and but instead of H2O, we can use the with a little bit different level of energy, like the CH4. That's a different methodology of generating hydrogen. But with this schematic diagram, you can understand the different level of energy, Y H2 and Y energy in and out. Okay. Now, when we understand the technology distinguished by different color, blue, gray, and brown, and black, and green, and now we can get some idea about the hydrogen how to generate hydrogen. So again, this is a different source, different reference, and production technology, steam reforming of natural gas with carbon capture and storage. This is blue. The point here is the cost. How much cost to generate CO2, generate O2. So there are some CO2 emissions, and cost is important the factor to evaluate each methodology. So we just learned that through a blue hydrogen we capture the CO2, but there are still CO2 generated, not fully captured per kilogram of H2. But compared to gray, there are you can see that can be reduced the CO2 by capturing. But so the cost is the gray is the I would say the lowest cost, but the blue has the moderate cost because we need to pay extra cost to capture the CO2. So but this one is also steam reforming of the methane. So steam reforming. This is the carbon capture and storages. Well, this is similar, but as you can see that how much the CO2 emissions. And the green, as you can see, we are using the totally renewable energy. Method electrolysis, and there is nothing but the water comes out. I mean the H2, H2 plus the O2. So there is no CO2 emissions, so zero CO2. We are using nothing but the H2O. So it's a very clean methodology, but it's very high. Cost-wise, is very high. Of course, the renewable energy is really free. Natural resources are free, but initial investment, installations of the wind turbine blade, installation of a solar cell cost a lot. So in terms of a total cost, which are needed to generate a certain amount of hydrogen, the cost is not small, it's very high. And actually, not only cost, we have to consider efficiency as well. Two characteristics, I would say three characteristics. Each methodology, how much the cost, how will be the efficiency, and how much the CO2 emissions. These can be very important three characteristics. The efficiency of the green, I would say 50 to 60%. And the gray is a little bit higher, but mostly order of 50 to 60 or 70, no more than 80, and sometimes less than 40%, depending on what kind of method you are using. And black, while this is the coal instead of direct use of a CH4, we are using coal. And brown, this is also coal. And then while moderate and high. So we like to understand the cost. Well, efficiency is not here, but cost and the CO2 emission. of course, we can get a better and more precise the information from our references. I just like to bring this issue relate to each hydrogen generation type, but the more detailed information can be found from references. Okay. And now this is also important. What's the current trend and what kind of technology are using hydrogen say, generation or production technology trend. So currently, or 2020, we start to use the gray hydrogen, but unfortunately, there are a lot of amount of CO2 are released together with H2. So CO2, we are using the reforming of CH4, but the CH2, and then now this CO2 needs to be is captured by CCS method. There are a lot of technology are being developed to capture this CO2. So this is much cleaner than gray. And but the natural gas is the main source of energy. So 2020 and 2030, by 2030, we aim to establish our method of a green hydrogen. So from water using through the method of electrolysis, with the energy source of a wind turbine blade and the solar cell, we can eliminate CO2 emissions. But again, all the energy generation and the method or industries really depends on the policies of energy policy of each country. Even Korea and China, India, and also United States. New President Trump, well, he doesn't like the green energy, green hydrogen, but I'm sure that he's wrong. So we have to keep developing the green hydrogen methodologies to better clean environment and the most effective energy carrier. So we have to put our efforts into how to effectively generate hydrogen, and then we moving toward the better hydrogen society, where you can move to cleaner environment, and also we can we will have the paradigm changes for different applications. Well, so transportation and storage, as you can see, the transportations and chemical industry and energy storages, and the tech is a liquefied and the export. So visualization of a three hydrogen production route and their denominations by specific color. As you can see that we are moving toward from a gray to a green. And I also believe that the pink, the pink hydrogen, which is related to the nuclear power. A nuclear power system can be also very clean energy source to convert the water into hydrogen. So the small reactor, modular reactor, SMR technology is being not developed. Okay, now actually the chapter 1, we need to review the property of hydrogen gas. So let's get back to hydrogen gas and hydrogen. Each material may have a gas form, water, and solid. So of course, so does the hydrogen. So hydrogen may change its density. So vertical axis is the density, and the horizontal axis is the temperature. So hydrogen itself can change the density depending on the temperature, but at the same time depending on the pressure. So this is important to understand the characteristics of hydrogen. This is actually should be covered in chapter 1 as an introduction to hydrogen, but I like to cover now. So the again, I'm sure this graph is quite new to, may be new to you. So let's pay attention to item by item. So this is the density. The density, the unit will be gram per liter. Okay, gram per liter. And then temperature. Of course, the temperature. Here is the minus 40. And here is the minus 253 Celsius. And then, well, about here is the, I would say, room temperatures. Here is the room temperatures. Now, but as you can see, even I would say room temperature, the density can increase. Density can increase. How? Well, as you can see, this line shows that pressure. So with a certain amount of the hydrogen can be compressed to and then density will increase. So I would say this axis is important: 180, 250, 350, and 500, and 700, and even 880 bar. While 700 bar is so high, I mean, all these bar, one bar is the atmosphere pressure. Very common pressure is 350, and also 700 bar. This is the real applications of compressed hydrogen. So here is the important number, and the 300 is also important density. So just for the for better understanding of the its real value, please pay attention or try to remember 40 gram per liter. Under 700 bar and room temperature, the density will be the 40 gram per liter, or 0.04 kilogram per liter. Okay, this is a very important number. 0.04 kilogram per liter under 700 bar, and also at 350, the density will decrease a certain level, but as you can see that this is a very important characteristics. Okay, so let's see here. We cannot get the exact number, But the point is that here is the 40 and the 20 half is here. But the pressure is the almost from 700 to 350. The density is not half, as you can see. I forgot the exact number, but some 0.0, like the 228. I'm not sure, but we need to double check. So point is that even though the pressure is reduced by half, the density is not reduced. In other words, in terms of efficiency, 350 is more efficient than 700 bar. If there are the same amount of energy, same amount of cost are needed, proportional to a bar, the pressure, I would choose the 300 bar, store the gas. Anyhow, but in terms of volume efficiency, of course, the a higher pressure will be better because with a certain amount of volume, we can store the more hydrogen. So 40 gram per liter or 0.04 kilogram per liter. This is an important number. Okay, let's get back to this 40 gram or what is the number. Okay, this is the same, but 40 gram per liter or 0.04 kilogram. Kilogram means, gram means that this is H2, okay, per liter. Under 700 bar pressure. Now, you may found some information through your homework. Let's get back to some reference. Necto, hydrogen car, say, well, the hydrogen tank and the volume. As I mentioned, there are 3 tanks of the 52 liters. So Nexo, this is Nexo here. Well, it says the 13 gallon, but that is the 52 liter. I'd like to find the other. Well, we briefly covered this topic, but I just want to give you some I like to relate the real fuel cell car and that how much the hydrogen are stored, why that much hydrogen are stored using this chart and characteristic chart. So again, the Nexo, as you can see, 70 megapascal is a 700 bar. This is the working pressure. And then tank storage density is a 5.7 weight ratio. This means that 5.7 H2 versus tank weight. And then where 44 gallon tank volume, this is the 52 times 3, as you can see, 3 tank. So this is the 156 liter, okay, 6 liter. So as you can see that this is a 700 bar, 700 bar, and the 0.04 kilogram of H2 per liter means that how much the hydrogen gas are stored. Well, 156 liter times 0.04 kilogram of H2 per liter, which giving us how much? So 6.2 kilogram of the H2 in full of tank and the at 700 bar. So once we fully charge, the Nexo will contain the 6.2 kilogram of H2. Okay, so to store this much hydrogen, the tank density is the 5%, 5.6% of the tank. So what will the weight of the tank is the 6.2 kilogram divided by the 0.057 is the tank weight. So this will give us about the 100 kilogram of tank weight. We can store 6.2 kilogram of hydrogen. And then I hope you remember the 120 megajoule per kilogram of hydrogen. This is the energy. And the so you can see that how much the energy can be stored. And then this is giving us the in terms of distance, we can run the about the 600 kilometer with a full charge. That's the characteristics of a hydrogen vehicle, Nexo. Now, if you are designer of the hydrogen storage tank as an engineer in Hyundai or so, now you can get the idea of how much the tank weight, how much the hydrogen gas can be stored, how much distance we can run. Of course, there will be some efficiency, but this is a rough idea, and then get the all the numbers relate to. And then, okay. So that's why this number 4.04 per kilogram per liter and 700 bar is the important. Now, this is a room temperature. How about the cold temperature? This is become cold. And you can see that this is a green. Green is I mean the yellow. This is a gas. This is a yellow is a gas. That's gas, and this color looks gray. This is the liquid, and this is a liquid. And between the liquid and gas, there is a cryogenic compressed hydrogen. So cryo means that it's very cold. So from here to these stages, is mainly gas, okay, mainly gas, but it is extremely compressed, extremely compressed, compressed. Mainly gas, but extremely compressed, and then cold. So, it's important to understand this trend goes up. Trend goes up. The density can goes up and up and up, and then the this is especially called cryogenic compressed, and we can have a sort of a half liquid, half gas, and then it's a compressed, completely liquid. So low pressure, like the 20 bar or 4 bar, is a 4 bar is a completely very close to atmosphere pressure. But here is uh, uh, the very cold temperature is the minus 253 C. Then the gas will become a liquid. So at the liquid, and you don't need to have a high pressure. The pressure can be very low. Well, you can say this is a very safe. We don't need to have we don't have apply a big pressure tank. We don't need a pressure tank. We just need a tank. But this tank has to be very cold, minus 253, to store the them as the liquid. But very interestingly, the density is important. Density is the amount of the hydrogen per given volume. So compared to here and there, you can see that how much the density, how much more hydrogen can be stored. So the pressure can play an important role to increase, and then also temperature can play a very important role of increasing the density. Now, so I would say this 0.04, this density is this much, okay, density. Now, let's say you become a fully liquid, let's say liquid at the 4 bar. 4 bar is the sort of like this. This is a fully liquid and almost atmosphere. The density is this much and this much. Now it's interesting compare the density. So this is about the 40 and this is about the 50. So, how much the hydrogen can be stored in a liquid? Well, compared to a 700 bar, there's not much, only 1.5 times, 40 to 60. Okay, this is many people have a wrong idea that if we have a liquid, we can have a lot of hydrogen, but that's not the correct concept, because even though it's a gas, 700 bar can give us a very high density. So that's why even though it's a dangerous, relatively dangerous to a liquid, hydrogen, high compressed hydrogen tank can be still widely used. Well, why this is widely used compared to a liquid, even though this is the 1 times higher? Well, to keep this much low temperature is not a easy task. You have to full insulations, and then a little temperature increase, giving us the hydrogen gas released, and then pressure will increase, and so we have to boil off the hydrogen gas to keep this much the liquid on the same pressure. So insulation is a big problem, and we have to waste some hydrogen to keep this much low temperature. So current technology, this much cost to keep this much low temperature is more expensive than keep uh, uh, compress the gas. That's why still hydrogen gas, compressed gas in a tank are widely used in automotive for Mirai and Nexo and buses and trucks. Uh, of course, we hope to move this trend. So as if we are able to keep the temperature, then we are good. We are it's better to in terms of increase the density. There's a very special bar. X2 means that twice. So twice means that 80 gram per liter or 0.08 gram if we have this is called cryogenic compressed. So if we have for example, 300 bar and here, as you can see, this is not a full liquid, still a little bit of a compressed gas, but uh, but pressure-wise, the almost half uh, than the 700 bar, but we have a much lower temperature than room temperature, but the density can be double increased. So density here, and density here, and density here. This is the 700 bar, this is a liquid, and this is the cryogenic compressed 350 bar is this is the highest. So this is a 2.0 times and 1.5, and I would say this is the compared to 1. So this is the most ideal point. We don't have to go into a minus of 53, but we have to keep the pressure like the 350, which is much safer than 700 bar. So later we will study more depending on this hydrogen state storage method. So anyhow, this is the density and the temperature and pressure relations. There is a similar, and this is a status 1, 2, 3, and 1 is the liquid, as I mentioned. 2 is the high compressed room temperature, and 3 is the CC, cryogenic, cryo-compressed storage method. It's not the, okay, 3 is okay, sorry, transcritical storage. So the cryogenic can be also here as well, 500, a little lower. Here is the current technologies. So the I reviewed this status relate to the chapter 1. Okay, chapter 1 as an important point that hydrogen gas, the there are some, we need to understand the property of hydrogen gas. While hydrogen gas, hydrogen itself is colorless and odorless and tasteless. And lacking natural cues for the detection. Okay, I'm not. That's why the density, temperature, pressure relation is critical. And when we study the here, there are a special method, a special hydrogen called white hydrogen. What is this white hydrogen? Let's find out. White hydrogen is called, it is a hydrogen, but which is naturally available. It's like a petroleum and natural gas, which are naturally available. But H2 is known that H2 is very difficult to find from Earth. Uh, so let's find more information about that one. Isn't it wonderful to have a hydrogen which we can dig out or the rise from the earth rather than electricity and the energy and then the reforming CH4. So white hydrogen is the one. White hydrogen, also known as a natural hydrogen, is a clean renewable energy source that's formed naturally in the earth. So this is the important. Okay, let's copy into here. The Earth's hydrogen, what they call factory, what does it mean? This is the ground level, deep inside, deep in the Earth. While I would say 2003, three. I don't know exactly how deep, but the point is that this H2O is decomposed, and we don't know exactly how this H2 captured inside the Earth. So all you need to do is just uh, we get the hydrogen. It's like the oil pumping. It would be very wonderful. And the so this H2 are caught inside the Earth. It's like the again, as I mentioned, the as good as the oil and gas. So so this is called the H2. I mean the white hydrogen. And first of all, how is this white hydrogen formed inside the Earth? Well, hydrogen is created by a geochemical reaction, mostly likely water and then a natural gas decompose into a hydrogen between the water and iron-rich minerals at high temperature. Is found in the Earth while subsurface along tectonic plates, both underwater and on the surface. So you can find many good information and as this. So if this hydrogen are available just from the Earth, well, there will be totally paradigm changes. And then, as you can see, and several decades ago, they found some hydrogen from Earth. This is not new, but that time, well, they didn't have any idea of how to use the hydrogen, so they just neglect the uh, white hydrogen. Now this from there are lots of activities try to find this natural white hydrogen. Imagine that this is available. We don't need to have any cost to generate the hydrogen, and then we can fully use of this hydrogen as energy. All we need to have is the fuel cell to generate the electricity, and then we can kind of really abundant energy source. Imagine this hydrogen is from a white hydrogen. That is the dream of our well, the energy demand. But again, this is not a dream anymore because they are saying that a lot of energy, the company and countries are trying to find the white energy, white hydrogen. If white hydrogen is available, in other words, the hydrogen cost is very cheap, like even less than $1 per kilogram of hydrogen. Then is okay. Together with this Nexo we just reviewed, I'd like to go into a little bit of Hyundai. The Hyundai is the one of the most advanced company in the world in terms of hydrogen gas applications to mobility. Not only Nexo, but also the buses and also eVTOL. eVTOL is this is the Hyundai released the eVTOL, electric vertical takeoff and landing. It is like the airplane, but the all using the electricity, and especially Hyundai, they are put a lot of energy rather than along with the battery power, but also hydrogen power. So Hyundai, their vision is not only as a automotive manufacturer, but also the eVTOL and also robot generation. Imagine that robot currently operated by the battery, but robot can be operated or powered by the hydrogen energy, and also eVTOL. They just Hyundai released this concept eVTOL, and this is not just the concept eVTOL. This is gonna be soon realized. So the future transportation hub brings together Suponar's historic visions of AAM. AAM, rather than AAM stands for advanced. I forgot the A. Advanced aeronautic mobility, something like that. But anyhow, the Hyundai is the one is the leading all the technologies. And if you are have a interest in working in Hyundai, you should understand the idea of the hydrogen power eVTOL, and besides the eVTOL itself, not only powered by the hydrogen gas, but all the structure has to be very light, for energy efficiency. So the structures can be made of the very light materials such as the carbon fibers and the composites, and so on. And together with the UAV or AAM, and there are new paradigm of the transportations. So while technology and industry out there is changing significantly, and we engineers need to prepare ourselves uh, to contribute to society. So but you can easily find this website. And also, I remember Hyundai started a new big branch. Uh, Not just the hydrogen, uh, HH, oh man, I forgot the name. Hyundai Hydrogen Mobility, or but anyhow, I'm sure you can find a lot of informations. Hyundai Hydrogen Mobility, there's a new divisions of Hyundai. Uh, Exient is a fuel cell trucks, and also while the infrastructures of a filling station is important, and the H2 ecosystems. So understanding current technology and what's going on out there, especially in Hyundai, as a leader of hydrogen transportations, we should study, we should prepare ourselves to get along with current technologies, especially led by Hyundai. So I just give you the bring this issue to you, a young engineer. But you are the one who have to lead this technology, hydrogen into a transportation, and contribute to a clean energy, and so on. Uh, so uh, the, I like to. I will just copy this one here for your references. Okay, so this is the old, this. So this is the class we covered today, and then I will share this the slide with you. Okay. Well, this is all the topics I would like to cover today. In book, this corresponding to chapter 2 and 3. And then please read the lecture note or book I distribute. Well, to understand the full, the numbers and this is also important, but more importantly, we need to get ready for the new paradigm of energy resource for hydrogen. Okay, well, thank you. And then this is all subject I like to cover. And as before, I will share all the lecture video, and then recorded in this Zoom class. Well, I much prefer to continue this class using the Zoom. It's much more convenient to use the Zoom recording and also refer to all the sites along with the classes and back and forth and saving all the lecture notes. I know sometimes it's not convenient, not as convenient as a face-to-face offline class, but is mainly due to your attentions. So please get used to this online class and then try to get more benefit out of this class, and then bring you guys capability and understanding of hydrogen technology. Okay, thank you, and see you next week. Oh, maybe next week I might have skip the class, but I will announce. Please pay attention to our announcement in Kato, and then there will be a homework weekly. Please submit the homework assignment on time as announced. Okay, thank you.